Welcome everybody to our introductory video on probability and statistics. So just to begin, before we really get into any really heavy-duty details, let's take a little bit to talk about kind of intuitive notions of maybe what probability is, and really that we've kind of got two different kinds. And the first kind of probability that we can talk about is empirical probability. Now, empirical probability is the probabilities that we get from performing an experiment. Now, probably an intuitive notion that you already have of probability is just, well, how likely is something to happen if we perform an experiment? How likely is somebody to get struck by lightning? How likely is someone to win a lottery? Those kind of things. And so our intuitive notion of probability really just comes from, well, how likely is something to happen when an experiment is performed? That's so the probabilities that we get from actually performing the experiments and gathering data, those are called empirical probabilities. The second kind of probability that we can talk about is something called theoretical probability. Now, theoretical probability are probabilities which come from some mathematical model of whatever it is that we're actually studying. Maybe we're talking about rolling dice or flipping a coin. Maybe we want to say that our coin is a fair coin and that coin is only going to land either on heads or it's going to land on tails, that we're kind of assuming that it's not going to land on the edge. We're assuming maybe that when we roll a die that the numbers 1 through 6 are equally likely to show up. And so in that, we are kind of starting with a mathematical model in our mind, and from there we can talk about what the probabilities will actually happen. Now, something to kind of put those together is called the law of large numbers. Now, what the law of large numbers says is that whenever we perform an experiment, that if we perform that experiment a large number of times, so we repeat the experiment over and over and over and over, and if we look at the empirical probabilities, so the probabilities that we get from the data when we run that experiment, if we look at those probabilities, then they are going to get really, really, really close to the theoretical probabilities, so the mathematical probabilities of whatever model it is that we're using for the experiment that we have. So some things that we'll kind of talk about in the course of our discussion of probability will be things called the sample space. Now, what in the world is the sample space? Well, again, coming back to this idea of an experiment, the sample space is just the set of all possible outcomes that we could have for the experiment. And it's in kind of looking at the sample space and determining the number of ways that things can happen. When we try to count those, that's usually where the difficulty comes in with our theoretical probabilities. That counting seems like an easy thing to do on the surface. We know we got 1, 2, 3, 4, whatever. Why would counting be so hard? Well, in some situations, counting the number of possible outcomes is a very challenging thing to do. And so kind of that's why in our discussion this semester, what we're going to be starting with is kind of looking at counting problems. So how do we take those things that are maybe difficult to count? How do we analyze them? How do we break them up? Look at them mathematically so that we can really count things that are not so easily counted. Another thing that we'll talk about over the course of the semester are things called events. Now, what exactly do we mean by an event in an experiment? Well, an event is nothing more than either a particular outcome from the experiment or it's a collection of outcomes from the experiment. So it's some stuff that can happen whenever we perform the experiment. That's all that we really mean by this notion of an event. So kind of looking at an example, suppose that our experiment is nothing more than rolling a fair six-sided die. Well, we can have one event A that's just going to be, this is the event that I roll a 6. Another event B might be the event that we happen to roll an even number. So A is an event where we get one particular outcome. B is an event where we have multiple possible outcomes in this event. We could roll a 2, a 4, or a 6 in that case. And so this kind of brings us to what we really mean when we're talking about the probability of an event. Well, the probability of an event A is just the number of ways that A can happen divided by the total number of possible outcomes the experiment can have. Now, something to kind of get used to in this particular characterization is this prob A. So it's the notation. What do we mean by some of the mathematical symbols that we're going to use? Probabilities, nothing more than fractions. Not a big deal. Hopefully we're all comfortable with fractions, adding, subtracting, simplifying, multiplying, dividing them. So fractions are not really, hopefully, are not that big a deal. If they're not, you may want to go back and find a good source to review those. But the notation for what we kind of mean when we are writing some of these things mathematically may start to get in the way. And so whenever we write this prob and A in the parentheses, if we're really reading that appropriately, so translating that bunch of symbols, prob, parentheses, A, close parentheses, translating that into English, we would just read it as the probability of A. So let's take a look at an example where maybe we are just flipping a fair coin. So what might our sample space be in that situation? Well, again, we're kind of assuming our coin is either going to land heads up or tails up. And so our sample space is just heads or tails. Now, what would be the probability of heads in that case? Well, probability of heads is just going to be the number of ways that we can get heads. Well, that only happens one way. And over the total number of possible outcomes, well, there's 2 possible outcomes, head and tails. So the probability of heads, 1/2. Likewise, the probability of tails is also going to be 1/2. There's one way to get a tails out of 2 possible outcomes, so probability of tails is just 1/2. So let's kind of bring this back again to this empirical probability. So what we just calculated a second ago was going to be the theoretical probability. Theoretical probability of a heads is going to be 1/2. Theoretical probability of a tails, again, 1/2. Well, what if we actually perform the experiment, but we perform it only one time? So we're going to flip the coin only one time, and suppose that the result is heads. Well, if we're calculating the empirical probability, so the probability from our experiment, the empirical probability of heads is just going to be the number of times that you get heads divided by the total number of times that you perform the experiment. Well, in this case, we were able to land on heads one time. We only performed the experiment one time, so the empirical probability of heads is just 1/1, or just 1. Now, the flip side of that, flipping a coin, get it? Pun intended, yes, flipping a coin. The flip side of that, the empirical probability of tails, is just the number of tails that you get when you perform the experiment divided by the total number of times that you perform the experiment. Well, we only performed the experiment one time. We didn't get any tails, so our empirical probability is just 0/1, or just 0. So kind of putting these things together, our empirical probability of heads, 1. Empirical probability of tails, 0. Now that is not even close to what our intuition says that we should get, of 1/2 and 1/2. So what's going on? The law of large numbers. The problem is we haven't performed our experiment enough times. So now let's suppose that I do a different experiment and I take a little bit of time off, go away, and I decide I'm going to flip a fair coin 500 times. Well, if I do that, here's the data that I got. So I had the number of heads that I got in 500 times, 218. Number of tails that I got, 282. From this particular experiment, now let's calculate our empirical probabilities. So our empirical probabilities, probability of heads, 218 divided by 500. If we put that in the calculator, we get a value of 0.436. If we take our empirical probability of tails, we get 282 divided by 500, or 0.564. Something that we notice in flipping 500 times, we're getting closer to our theoretical probabilities of 1/2. 0.436 and 0.564. Those are fairly close to the values that we should be getting. And so here we do see the beginnings of the law of large numbers in action, that the more that we perform the experiment, the closer we get to the theoretical probabilities. And so this kind of raises a question, will we ever actually get the 1/2? How many times do we have to perform this? Well, that's one of the problems in statistics, is that we don't know how much data is enough. Well, we never really have a concrete answer to that question, and probably the real answer is we'll never get there. Okay, so that you'd pretty much have to perform this experiment an infinite number of times to ever get our 1/2 at that point. And so kind of in this course, we've got kind of 3 different components that we're going to be looking at. And kind of the first kind of big chunk of the semester, we'll be looking at counting problems. So how do you take some of these things that are really kind of complicated situations, and how do you break them down and analyze them mathematically so that essentially you're just counting possible outcomes of things. From there, we've got our theoretical probabilities. So the counting problems lead to our discussion of theoretical probabilities. That's kind of our second big component of the course. And then finally, where does the statistics part start coming in? Well, you can really kind of think of statistics as being applied probability, and really kind of answering the question of how do we use the results of our experiments to really determine if our theoretical probabilities are right. So we've got this model of how we think things should work. We make our calculations from those. Then we go over and we run the experiment. And then we go back and we check to see, is what we're getting what we should be getting in our model, knowing that law of large numbers, we may never perform the experiment quite enough. But can we say with reasonable certainty that our theoretical probabilities are actually right in that case? And so that's kind of the thing in what is statistics. You're really kind of doing your best to use data to determine whether things are going to be true or not, but knowing that you're never really going to be able to do this, because mathematically you're going to be guaranteed to be wrong a certain amount of times. So that's where, can you really prove anything beyond doubt with statistics? Not really in a strict mathematical sense. You're never really going to be able to do that. And so hopefully this is kind of giving you a little bit of an introduction to maybe some of the things and some of the ideas that we're going to be using throughout the semester, just to kind of get you thinking and used to some of that terminology. So glad to have you aboard. This is our first video, and hope you have a wonderful semester.